औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम। कैसी हैं क्लास? खैरियत से हैं आप लोग? ठीक ठाक हैं? अल्हम्दुलिल्लाह मैं ठीक हूँ। उम्मीद है आप लोग ठीक होंगे। अच्छा जी, in today's lecture we will discuss the radar and its basic operation and principles. Here is the outline of today's lecture: introduction to radar, history, basic radar principles, component of radar system, types of radar, factor effects on radar, then some advanced technology like steel technology, advantages and disadvantages, application, and then to the lecture conclusion. First of all, what basically radar stands for? Radar stands for radio detection and ranging. That it means that to detect by using the radio technology and to elaborate the range of the detected object using the same radio technology. That means in this technology we will use the radio waves to detect the object as well as with the distance or the range of the that identified object. Working process of radar. We all know that from initial studies and from bachelor's and master's previous knowledge that we have heard so many times given examples by the teachers that bats uses a basic form of radar. They send sound waves that reflect from an object just as electric radar systems do. That means that it is the technology that have been more uh, defined or that has been discovered or motivated from an bird that is called bat, and that technology has been recognized from these bat techniques that they uses to identify their prey. Okay, the history, as we are continuing the working in the history. The history of radar starts with experiments by Heinrich Hertz in the late 19th century. The first form of the radar is being shown here in the diagram below. That is telemobile scope. That is the first form of radar. It was mainly used to detect ships to avoid collision. So first it was used or developed for the ships in order to avoid the collision when there is a fog or in the winter when there is a fog presented. The system is used to detect the ships in order to avoid the collision. Here is the frequency bands in which radar works. These green channels are defining the radio frequency bands for radar. Radar works on different frequencies in different bands, as it has been seen by the green belt that it works on some of the frequencies in HF, and some of the frequencies in VHF, some of the frequencies in UHF. Then it also works on LSC X, XU, X, XA, V, W, all of the bands. In almost all of the frequency bands, radar works, but for a little band, that is not for the whole band, but for a little of the frequency from the specific band. Okay, what is basically the principle of operation? The principle of operation for radar is to transmit the radio frequency and receive the echo of that frequency in a specific time by which it identifies the range or the distance of the object from the specific source. That means a radio wave has been sent in the air, and when it gets hit by the object, it reflected back. And as it reflected back, there is some time of upcoming and upgoing, or upcoming or incoming or outgoing. So it calculates the upcoming or incoming or outgoing time, and then in a result, it gives the distance of the object also, same with the identification. The range of the radar can be found by a formula. That is, it means that in a specific range at which the radar works is the is it works in the specific area. The range is called range at which it is effective, and that is found by the formula that is CT by 2. That is, here C is defined as the velocity of the sound, that is 3 into 10 to the power 8, and T is the time from the source to the object and return and back to the source. This whole cycle time is used in the formula, and it is divided by 2 as the pulse have to go for the uh, go for the 2 rounds, that is from source to object and from object back to the source. Okay, we all have heard a phenomena that is called Doppler effect. What basically is Doppler effect? Doppler effect is basically the change in frequency that occurs when a signal hit the target in a relative motion. That means if a signal is being sent in the air for the detection of an object, and uh, when it gets hit by the object and the object is in relative motion, the frequency of that signal that has been sent to detect the object has been changed on the return, and that change in frequency by the relative motion of the object is known as Doppler effect. The Doppler effect can be used in a continuous wave radars in order to determine the velocity of the upcoming or the detected object. There is a little bit of recall Doppler effect theory. The frequency is equals to 2v over lambda, and here Fd is the Doppler shift, v is the relative velocity of target, and lambda is the wavelength of the source frequency. So that is the Doppler formula. A basic uh, a basic radar system. A basic radar system. We have a transmitter and a receiver here. There's a switch between the transmitter and receiver. If the signal has been transmitted, it is towards the transmitter, and if the signal is or the antenna is in the receive condition, the switch is on the side of the receiver. This switch is basically used to transmit or receive once at a time. This switch is basically for to control the transmission and reception of the radio signal through the antenna. That is the antenna which transmit pulses and also receive pulses. That is the from the receiver, the data recorder has been connected in order to display the radar activity. Here is a little bit operation of the radar in order to understand to make us understand the operation of the radar. That radar creates an electromagnetic wave that is focused by an antenna and then transmitted through the atmosphere. That is the same phenomena that has been discussed previously, that radar creates the electromagnetic wave through the antenna and transmits it to the surrounding or to the open air, that is atmosphere. It is also printed in the figure that the antenna is transmitting this electromagnetic wave. After that, objects in the path of the wave called target, object in the path of the transmitted EM pulses called target or echoes scattered most of the energy, but some will be reflected back toward the radar. That means if an object or the target comes in the way of the transmitting wave, it returns back the echoes. Most of the energy is being scattered, but some will be reflected toward the radar. That has been defined in this picture. Defined in the picture that energy is being returning back. The receiving antenna normally also the transmitting antenna gathers back scattered radiation, feeds it to a receiver. Then the signal is received by the antenna and given for to process to the receiver circuit. Then an EM pulse encountering a target is scattered in all directions. The larger the target, the stronger the scattered signal. It means the received EM pulse encountering a target. That means an reflected EM wave that has the target information. If the pulse is scattered in all the directions, the larger the target, the stronger the scattered signal. That means a pulse that has been received is scattered if the scattering if the scattering is stronger. If the scattering is stronger, that means the object is larger. Then it also has the ability to detect more than one targets, and if more than one target are detected, the stronger the return signal, which identifies that more than one targets are on the way. The radar also measures the return signal, generally called the reflectivity. Reflectivity magnitude is related to the number and size of the target encountered. That means if there are more than one target, the radar measures the return signal magnitude and the number of the return signals, as this number and larger magnitude indicates that there are the number of targets that are coming towards. A duplexer is the main part of the radar, in which the duplexer is actually a waveguide switch. It passes the transmitted high power pulses to the antenna and the receive echoes from the antenna to the receiver. Duplexer switches automatically based on the timing of control signal. There is nothing to be confused. There is nothing to be confused of, because here the duplexer is the switch that has been defined previously in the block diagram of the radar. That switch, and that switch is known as duplexer. This duplexer is basically is a waveguide switch that is used to passes the transmitted high power pulses to the antenna, and also as a work to receive the echoes from the antenna and transmit and forward it to the receiver. And that duplexer works, and that duplexer switch, and that duplexer is connected with a switch, or it also itself is a switch which automatically switches from transmitter to receiver or receiver to transmitter on the basis of the control signal that has been generated timely by the system. So moving forward to the antenna system that had been used in the radar to transmit or receive the signal. The antenna system basically used in the radar is the directional antenna. The energy is focused in a given direction and also focused to receive the energy from the specific given direction, which allows the energy to travel or receive further in a constant manner in order to achieve the highest gain, which as compared to the isotropic source. This is the antenna pattern, or the signal strength pattern of the antenna shown here. Basically, two beams are shown here. One is the inverse cosecant square beam pattern, and the second is the fan beam pattern. The balloon type is called fan beam pattern, and that pattern is graphically known as inverse cosecant square beam pattern. They both are used for coastal surveillance and vessel traffic systems. Now moving towards the type of radar, we have basically there are two main types of radar: primary radar and secondary radar. Secondary radar have no further types, but primary radar have two further types, that are continuous wave and pulse radar. That means a continuous wave have been sent in the atmosphere, are known as continuous wave radars, and as we transmit the pulses or the train of pulses in the form of frequency of radio signals, are known as pulse radars or pulse wave radars. Further, continuous wave radar is divided into two types, that is modulated and unmodulated. That means the waves that has been used to in the radar is modulated or unmodulated. If it is modulated wave, then it come under the category of modulated continuous wave primary radars. And if the continuous wave is unmodulated, then it comes under the category of unmodulated continuous wave primary radar. Then in the pulse or in the primary radar second type, pulse radars, pulse wave radars have further two types, that is MTI and Doppler. MTI is used for stationary uh, objects and Doppler is used for the moving objects. That is the difference on the radar types. There are no further type of radar in the secondary category. Now the factors that affect radar performance. There are many factors that can affect radar performance. Signal reception. Definitely the signal reception is not correct, or the signal is not directly received, then there is a problem in the performance of radar, or issues have been created. The receiver bandwidth, pulse shape, power relation, beam width, pulse repetition frequency. If the pulse repetition frequency is somehow varied, varied more, then the radar is not able to detect the object efficiently. Of course, the antenna gain, a high antenna gain, a high gain antenna is used in order to in order to increase the performance of the radar. Yes, radar cross section, radar effective area should be more. Signal to noise ratio. If this signal to noise ratio is basically the factor of that is the natural factor maybe, as if there is a fog or if there is a rain or there is other atmospheric extreme condition, then the signal will be distorted and the noise will be entered in the signal, and that disturbs the signal to noise ratio. Then receiver sensitivity, definitely if the receiver is not that sensitive, then there should be a problem in the radar performance. Pulse compression, that means if the send pulse or the transmitted pulse is compressed more than the given range, then the radar performance is affected. Then the scan rate, definitely the switch or the duplexer that is used as a switch, if not working in the range or scanning or switching more, then there is definitely a problem of performance for the radar because as the switch goes through the transmission and the reception, if it doesn't end it, there should be an error and also can damage the radar. Carrier frequency, we have to choose the carrier frequency very intelligently. Then the antenna aperture, yes, basically, definitely antenna also, antenna size, antenna aperture, antenna cross section, they all are very important factors that can affect the radar performance very easily and can identify the false object with a false range. Now moving to the steel technology, somehow it's not our not included in the course, but I think it is better to give you some know-how of the steel technology. Basically, steel technology is depend on the four main factors. Number one is the material of the steel that has been manufactured with. Second is the shape of the steel, directivity and orientation. That it also has the transmission system. So the transmission directivity and orientation are also important in the steel technology. Third is the active cancellation, that it can have the transmission system, so it has to be a some noise cancellation system, so it should have active noise cancellation. And the fourth factor at which the steel technology depends is the radar absorbent paint, that is the special paint that been used on the steel planes in order to absorb the radar energy. So these are the main four factors on which the steel technology depends. Number one is the material. Okay, the first thing is the material. As we all know that the metal is the highly reflective for radar or any radio wave signals. So, in order for the material to be used to build the steel technology or the steel planes, it is not the metal, or the metal is very less used in the steel technology. More plastic and fiberglass are used, rubber mountings are used in order to avoid the radio frequency reflection. For an example, submarines have extensive usage of rubber mounting in order to isolate and avoid mechanical noises and some reflective some reflective signals in order to avoid mechanical noises and reflection of the frequency signals. Then the second factor that have been discussed in or the main uh, component of the steel technology is the shape, directivity, and orientation. The second point indicates that the surface of the steel are designed in such a way that the surface are designed in such a way that the reflection will be uh, highly reflected, highly sorry, the surface are designed in such a way that the signal or the reflection is highly scattered, in which it is very much difficult to identify the object as well as the distance of the object. And also uh, in steel technology, it is also being concentrated on the edges, that Edges should be sharp, not round, because the round surfaces will often provide the normal to the surface at which the radar signal can be highly reflective. So it is also been concentrated on the factor that the edges of the shape should not be rounded, it should be sharp. Okay, so the summary is this, that the shape and the material are designed in such a way that the reflection of the radar signal is uh, highly avoided, and the edges are also being designed in such a way that they should not be round. Surface edges should not be round in order to scatter the signal as more as possible. The third factor is the active cancellation. In active cancellation, the target generates a radar signal equally of same intensity but in opposite phase. This has been done in order to cancel out the upcoming radar signal, and this when interfere have created the destructive interference, and the radar doesn't get any signal reflected. So this is the active cancellation that has been used in the steel technology in order to avoid the detection. The fourth and the most important is the radar absorbent paint. A special paint is being designed only for the steel technology, which contains the special iron balls. This special paint is basically uh, works as it absorbs the radar signal energy and convert it to the heat energy in order to uh, wipe out the radar signals. So this is the special paint that has been designed only for the objects or objects or the uh, flights that are not known to be detected. I think that's all. No, 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 we will go further. We will go further. Okay. So there are some pictures. That is the steel plane or steel planes. You see, that's all for today. Inshallah, we will discuss most further things related to the radar in the next session, inshallah. And thank you very much. अपना ख्याल रखिएगा. अल्लाह हाफिज़.